So Schrodinger came up with these things called wave functions to help deal with the idea that we need to deal with more than one electron systems. So a wave function is math that describes the energy state of an electron. And we aren't going to expect you to do any calculations with it. You would do that in physical chemistry. The wave function squared is proportional to where you can find the electron. What these essentially are is they design different shapes that you're going to find the electron in. So then we have Heisenburg uncertainty. And Heisenberg worked with Schrodinger. They both were contributing articles at the same time. And Heisenberg was saying, you cannot know both the position and the momentum of the electron at the same time. Momentum is when you have a stop sign, and if it's hit by someone who's a runner versus hit by someone by a semi, even if the semi and the runner are going the same speed, you know that the effect on the stop sign is going to be different. Momentum is mass times acceleration. And so it's kind of like the velocity of the electron, but it's more than the velocity of the electron. But anyways, you can't know both basically the movement and the position at the same time. That's because to catch the picture of it, you're actually freezing the electron, and therefore it no longer has movement. So Schrodinger and Heisenberg show us that the electrons are in regions of space of the atom, and that they decided to call them orbitals. So keep it straight. Bohr put electrons in orbits, like planetary orbits. These are electron orbitals, and each orbital subshell contains 2 electrons. Wave-particle duality described by Schrodinger. And then quantum theory of electrons. So far, electrons can exist in only one energy level, not between them. And Bohr theorized that the energy was quantized into orbits, so that's true. And the electron can jump between levels, but it can't transition smoothly. So those lines may not have been the best choice. It kind of looked like a smooth transition. But what they really can do when you're looking at the levels is that the electron can jump from here to here, so he can jump. But it's not like he's transitioning through all of these in his jump. The best real life, or the closest one that I've ever thought of, is when you're looking at stairs and the electron can be here and or here, but you can't pause in midair between the steps. So he either exists here or here. That video I was showing a few videos back kind of explains and shows it, where he's either in one orbit or in a larger orbit, but there's not like an in-between. It like jumps between them. This is a unique thing about all these different little quantized particles. So they can jump the levels. It's not like an escalator. And we label them with 1, 2, 3 using positive integers. So this is the first, that's the second. Electrons can have both wave and particle characteristics. And Schrodinger and Heisenberg redefined the movement as resembling orbitals, which are regions of electron density of varying shape. They disputed the idea of electrons in orbits and supported the idea of orbitals.